The last video in Unit 5 or Chapter 14 is on catalysis, or the process of a catalyst working. There's lots of essential knowledge that you can read through here. We'll go through all of it in the notes. So first of all, what is a catalyst? And you probably know this from previous science classes, but a catalyst is a substance that speeds up the rate of a reaction. What most students don't quite understand is why or how does a catalyst do that? It seems like it's just magic. And we're going to talk exactly how it does that. First of all, a catalyst, one requirement of a catalyst is that it is not consumed in the chemical reaction. Because if it was consumed in the chemical reaction, it would just be considered a reactant because it would disappear. A catalyst is not consumed. Often what happens is it reacts in the first step and then is produced in a subsequent step. So overall, the catalyst doesn't, it disappears and then it reappears. So the same amount is present at the beginning of the reaction and at the end of the reaction. How a catalyst works is by providing an alternate mechanism. So we just learned about mechanisms, the exact steps, collisions that need to take place for a reaction. If you add a catalyst, what you can do is have the same reactants, have the same products, but the collisions change. It's just a different way of getting from start to finish. If that different way of getting from start to finish has lower activation energy, then that means that more molecules will have the energy to overcome the activation energy. There will be more successful collisions, which will mean the reaction speeds up. You can see that's exactly what's happening here of the reaction of, what is this? The reaction of hydrogen peroxide, right? And if we add the bromide ion there, you can see it's also in the products, right? And so it's actually the hydrogen is in the products as well. So those would be considered catalysts because they are present at the beginning and they're present at the end. But look at this. Because the uncatalyzed reaction has such a high activation energy and the catalyzed reaction has a much lower activation energy, then more molecules will have enough energy to overcome the activation energy and the reaction will proceed at a faster rate. Here's a picture of that Maxwell-Boltzmann distribution that shows us the range of energies that molecules have at any temperature, particles have at any temperature. There's always some that have little energy, there's always some that have a lot of energy. And what this is saying right here is that if you look at this line, and all these molecules, this represents the fraction of molecules that have enough energy to overcome the activation energy in the uncatalyzed reaction. Notice I haven't changed the actual distribution at all. So this is at the same temperature. If I add a catalyst and I lower the activation energy, now there's all of these molecules and these molecules have enough energy to overcome the activation energy. So therefore, the reaction will proceed much quicker. So another aspect of catalysis or a catalyst is, well, what state of matter is it in? If it is in the same state of matter as the reactants, most reactions that we talk about are aqueous. And so if it is also aqueous, we would call that a homogeneous catalyst. There's nothing really special about that. There is something special, though, about a heterogeneous catalyst. A heterogeneous catalyst is when it is in a different state of matter. And this is almost always when it's in a solid state. The catalyst is in a solid state, maybe where the reactants are either gaseous or they are aqueous. Because it's in a different state, because it's a solid, surface area starts to become important. Because if I have a catalyst and I just have a literal cube of it, has very little surface area. But imagine then if I take that cube and I pulverize it into a powder, then there's much more surface area. Therefore, more collisions can take place with the catalyst and the reaction will speed up even quicker. So especially with a solid catalyst, surface area becomes very important. And one really important aspect of catalysts are enzymes. Enzymes are biological catalysts. They're proteins. And Enzymes are involved in almost every chemical reaction in the body, helping the reaction to happen at a quicker rate by lowering the activation energy. Usually the way that an enzyme works is that it actually the enzyme will bind to one of the reactants. We call it a substrate. The enzyme will bind to the substrate, therefore usually increasing the chances that the orientation of the collision is within proper orientation to actually make the reaction take place. So you can see in this diagram here, the uncatalyzed reaction has a activation energy here, and the catalyzed reaction has a much lower activation energy. And since it has a much lower activation energy, you get this distribution being set up where lower activation energy, more molecules have enough energy to overcome the activation energy. Therefore, the reaction happens quicker.